Alright guys, welcome back to another Roblox game development slash coding tutorial, and today I wanted to show you guys a way to set up your games for game development using object-oriented programming. If somebody was like, hey, create a game using object-oriented programming, I would probably create it somewhat similar to this, and I'm going to show you the official setup that you really should be using when you program using object-oriented programming inside of module scripts. Most of what you've seen has been building up to this, but now I'm going to show you like the official way of how it's done, or the traditional way in which it's done. And this should be really informative for most of you all. First thing I would say is just make sure you have this plugin installed. This is the tag editor. To get this, you'll just go to the toolbox and you would go here to plugins, and then you would just type in tag editor and it should pop up. See here it is. As you can see, I already have it downloaded. Go ahead and scroll this over just in case you can't see it. It's right there. But yeah, so this will be a really good one for you all to see. And without further ado, let's go ahead and get started. So I'm going to go ahead and create a folder inside of server storage called classes. This is generally the folder where I put all of my modules for everything. You could also create another folder called like services as well. I think that's a good thing to do. You know, some stuff there, and you can also create another thing called like components as well. I've seen some people do that, but today we're just going to focus on like the classes, so you don't have to worry too much about this services folder. I'll show this when I show how to actually make games, or how I actually do it using the Arrow game framework. I would show how this folder works, but for right now we're just going to stick with the classes folder. Oh, I misspelled classes. There we go. Alright, let's go ahead now, create a module script inside of here, and I'm just going to call it example class. So come back out, we're going to call this example class. And I recommend that you name things here, and I made a mistake in one of my older videos. I talked about camel case and Pascal case. I flipped them. This is Pascal case. So Pascal case is when you start every word with a capital letter. Camel case is when the first word is lowercase and then everything else starts with a capital letter. I like using Pascal case for my modules, and then camel case for my variables, and then Pascal case for any functions to distinguish what is what. But let's go ahead and look here. So I'll have this example class, and I'll call this again example class, and then go ahead and just take this right here, copy it down, paste it here. Cool. And the first thing we're going to do is we're going to call a meta method here. And essentially what this meta method is going to do is whenever example class is called, whenever I call this thing to do something, that's when you index something. So like whenever you hear the word indexed, right? So let's say I had local array here, and I have, I don't know, an array, and then I have like 1 in it, right? And then 0. Whenever I do like something like this, print array, and then I put braces in the first element, this is called indexing. I am asking Roblox to tell me, here I'll zoom in so you guys can see here, I'm asking Roblox to essentially grab the first element here. So this is known as indexing, this right here. And then obviously if you have key value mappings, it's the same thing. So whenever my class is indexed, example class is indexed, I want it to return my example class. So essentially it's going to return everything that's stored in here. So every time this is indexed, it's just going to return everything in here, and that's a super important thing. Okay, so that's why you need that there. Then the next thing is I'm going to define what it means to have a new example class, right? So let's go ahead and define here. We have an example class dot new, and this is going to be a function. So I'm creating a new class object here, and I'm going to pass no parameters here. I'm going to enter down. Okay, now with that being done, I'm going to go ahead and create the self variable here. So again, just in case you don't remember, self resembles an instance that essentially calls this function. So if I did, local new equals example class, hold on, I don't know why I didn't come here. Example class dot new would represent the variable self, right? The same way that if you created local new and you did vector3 dot new, in the way that this was programmed, probably either in Lua or C++, they use self here in this method as well. So let's go ahead and look at how this works. So the next thing you're going to want to do is you're going to want to go and type in local self, which describes the instance calling your class. We're going to set this to a metatable, which means that the first thing we're going to type in is the table that's getting its metatable set. So normally, you'll see sometimes when you do object-oriented programming, they just do an empty table here. Well, the thing with this is that this doesn't extend to everything else that could potentially be stored in this table. But now, when I do set metatable, not only am I creating an empty table for self, but I can also include everything that is stored in the example class. So it's not only an empty table, but it's also going to extend all the things in this class. So if I create functions here, right, my new is going to extend from that, right? So if I created a speak or something, right, or just some arbitrary functions in here, it would extend. And then if I also created other things down here, like example class, function example class ass colon whatever. If I did this, it's also going to extend that as well. And you actually want to put this up here, so that way I always like to put my new kind of at the end of everything, so I know everything that's in the index. And then I would tab this. Actually, we could have this over kind of like this. In my VS Code setup, I don't have it indented like this, but now I can index this because whenever this is called, this creates a method in the class. This adds this to this. And then whenever I do set metatable here, it's going to pull all the things from example class and add it to my self variable here. And that's why this line is so important. Okay? Then the last thing you're going to want to do here is you're going to want to return self. Principle of object-oriented programming, whenever you create a self, you need to return the self. And this is the standard setup. I would write this down. I would put this somewhere. This is your standard object-oriented programming setup. Most of the time when you see object-oriented programming done in Roblox Studio, it follows this general template here for a class. So let's go ahead and see, how you can use this and how it can be practical. So let's think. What do I want to make today? Let's make like a dog, I guess. We can make a dog, right? Shouldn't be too hard. Let's see. So the first thing I'm going to do here is I'm going to create the leg of the dog. So let's do self.leg. And I'm going to set this to an instance of a new part. Okay. So we'll call this leg 1. Right, and then I'll go ahead and, again, this is why I love VS Code, because now I can, instead of having to do it this way, there's an easier way to do this in VS Code. But I'll create our 4 legs here. Cool, and then probably like a body. And then maybe like a head. Right, so here are our 4 parts, and then I can actually do something here, as I can actually create the parent right away, so I can do self.parent here, and then set this to workspace, and then I can pass workspace in here. Oh, excuse me, no, I don't want to pass workspace in here. What I'm actually going to do is, it should be self.parent here. So now you could do comma and do self.parent, because I've already created parent to workspace. So if I ever want to change what the parent is, I can, right? because now I've created this as a variable upon instance. Right, and as you can see here, I've created 4 legs, a fourth leg, and a body and a head. Okay, now I probably want to create positions for this. Let's go ahead and create a self.position variable. Let's set this to vector3 dot new, and we'll set the position of this to 0, 0, 0. So it's just in the world. Okay, all right, so we're going to go ahead now and create the variable for the self.legs position. So self.leg1 should have, we'll go leg 1 here, dot position, because it's a part, right? So it's going to have a position here. And we're going to set that equal to self's position plus a vector3 dot new, where you can kind of offset the leg a little bit. So let's say it's set off by like 2 in the x. So it'd go forward 2, and then leg number 2 is going to go back 2. Then leg number 3 is going to go the other direction. And then leg number 4 is going to go back 2 in the other direction. So I'll have 0 and then -2, right? And then the body is going to go ahead and go up. You know, we'll do 0. We'll go ahead and do like 5 here. And then the head is going to be hard to think about. This will be probably, let's do 2. Well, that's going to go where that is. So probably the center would be 2, 2, and then 6. Okay. All right, so there you go there. And then now we can do the size of everything. So leg 1 is going to have a size. So we're going to go ahead and do self.leg1.size, and I can set this to a vector3.new. Okay. So right away I can already see that I can make this a little cleaner, and I'll show how in a second. But what you can actually do now is let's think. So this is going to go out 2, so we're probably going to want this just to go straight up. So probably just like a base here, and then it's going to go up 5, and then have a base of 1, kind of like that. And I think this would be a good size, so we'll go ahead and do this as self.leg size here, and I'm going to set that here. And then I'm going to go ahead and call this and say self.leg size right here, right? And then this is great because I can keep things dry, so I can go ahead and do leg 2, 3, and 4 the exact same way. So we'll go ahead and do leg 2 here, and then leg 3. Oh, I forgot to change this up, didn't I? So this should be here. Good idea here is probably just to divide this all up, so it's very easy to see where everything is. This is now leg 3. This will be leg 4, and then this will be the body, and this will be the head. So as you can see, I need to change this up. Okay, so back up to here. Here's leg 1s, and then leg 2s are right here. This is your leg 3, and this is your leg 4, and this will be your body, and then this will be your head. Okay, all right, and as you can see, kind of a nice little setup here, and I'm actually going to make this 7 because I think this would be better. Cool. All right, so now we have self.leg size, self.leg size, and then we'll go ahead and copy this. We'll have 3 now for leg size. Okay, so this is leg 3, and this will be leg 4, and this will be body. Now body is not going to have that leg size, right? Because that just wouldn't make sense to have the leg size be that for the body. So the body needs to have, I'm actually going to create a variable here for body, and we'll go ahead and do body.size here, so body. So if I'm thinking about this, I'm going to go ahead and come up here and create a variable here, call this self dot body BODY size here. And what we're going to do is, since I know the legs go up 5, I know the body is going to be positioned there in the center. And everything goes out 2, so this probably needs a size of vector3 dot new, and it's going to extend out in the x2, 0 here, and then 2 again. Okay, so essentially, or this needs to be 1, my mistake. Okay, there you go. And then you have self.head, body size is going to be self here, dot body size. Boom, cool. And then self.head is going to be a head size. Let's go ahead and create that up here. Come here and do head size, boom. And we'll just make this like a 1, 1, and 1. This may be a really small dog. I guess we'll see, right? Cool. And then we'll come here and we'll go ahead and do self dot head dot size is equal to self dot head size. Cool. All right, so now I've kind of declared everything here. And yeah, things are looking pretty good. The only thing I think we should probably change is, let's see here, we should probably create a can collide and anchored property, but I'll just create an anchored property. So we'll do self.anchored, CHORED, and we'll set this to true. And then now what you can do is you can do, last but not least, we'll do self.anchored or self.leg1.anchored is going to be equal to self.anchored. Boom, and we'll go ahead and go to 2, 3, 4, and all of that good stuff here. So we'll go ahead and create a 2 here, and then we'll go ahead and create a 3, and we'll go ahead and create a 4. Let's this down a little bit. Here's our 4. Go ahead and do the body. And then go ahead and do the head. And I think this should pretty much be good. The only thing I could see happening is that the part kind of falls at the start. So maybe instead of declaring the parents here, what I'm actually going to do is, because right here, what may happen is it may instance before all these properties are set. So I'm going to go ahead and do a last thing here and do self dot leg1 dot parent here is going to be the self.parent. And I'm doing this because if I set the parent here to workspace before all this is initialized, it may just fall out of the sky, which is not a good thing. So it may fall and then all of this initializes, which wouldn't be good. So I'm going to set the parent at the end so that way the object is created, then initialized in the game, if that makes sense. And I'll classify initialized as the parent being changed to workspace. So this gives it time to load and all that good stuff before you see it. Cool. Here's your leg 4. And then here is your body. And again, in VS Code, this is much better. So if you guys know how to sync up with Rojo, do this because I hate having to copy and paste like this. But for the sake of this video, if you haven't seen that yet, I don't want to confuse you. Alright, so here's a good example class. This turned out to be a dog, so why don't we go ahead and rename this to what it is. Let's call it dog. I don't feel like renaming everything. But you guys get the point here. So now that I've created this example class, I just need to now initialize it in the game. So to do that, I'm just going to create a script here, and you can call this your, init.lua. Let me see, init underscore init underscore.py. Oh. Wrong programming language. My bad, guys. We'll just call this init. Or you can call this app or main. You can call this whatever you want. But, yep. So then now you do is here, local example class is equal to require. And then this is going to be game dot server storage. It's going to take your path variable, classes, and then where is my example class? There it is. And fingers crossed, I think I did everything right, but I could have made a mistake. New. And as you can see, I can set this to a variable now. So local dog is equal to this example class dot new, right? And now I actually have access to dog dot leg1 dot, and look at that, all the stuff. I can change it all right here, and that is why object-oriented programming, ladies and gentlemen, is so awesome, because I've declared this object, but I still have access to everything. As you can see here, it's all stored in this table. So I'm going to go ahead and print here dog, so you guys can see, how this was essentially made, assuming I didn't completely mess it all up. All right, let's go ahead and run here. Move our spawn point out of the way. Oh, it initialized okay here. Let's see. As you can see, we have our 4 legs. Looks like the body got a little bit out of place here in the head. That's okay. Let's see. But as you can see, the concepts are still the same here. We can actually probably model this and just copy the positions and sizes and stuff. So, interesting. Okay, so this would have to come over here like this, and then over here like this, and then over here like this, and then here like this. Okay, then this would have to come over, and we'll just move this down. Cool, cool. Alright, so let's see here. So this position should have been 2, 4 for the head. So this should have been 2, 4. So let's go back to my example class. Head position should have been 2, 4. Self-dot position was 0, 0, 0, so this should be 2, 4, 0. Okay, then that should save, I hope. Size didn't change. If I come back here, I can click on this, and then this is the body, so this is the size of the body. So the size should be here, body size, boom. And then let's get the body position as well, which was offset by, it looks like 3. So it was 3. So a little bit of a mistake there. And then obviously you can customize and change all the stuff. Boom. Okay. Alright, so let's go ahead and stop. Hopefully it just doesn't change anything. Looks like it saved my stuff. And again, that's a great thing about, again, VS Code is when you make edits, you can actually make edits like that while your script is running. And again, that's why you should all be using VS Code. But I think this should work now. The head didn't quite get to the right place. Body's fine now. Let's see what happened with the head. Head 2, 7. Oh, did I not move it correctly? Should be like right here. 2, 4, 2. Yeah, 2, 4, 2. Come back down here at 4. Boom. Here we go. And go ahead and do this. Boom. And as you can see, I've created, well, 2, 4. Maybe bring the head over a little bit. One more stud. Hold on, guys. Almost there. Let's see. How much do I have to bring this over? 2. So position is 2, 4, 0. 2, 4. Oh, 2, 4, 0. Ah, super close. 2, 4, 0. Alright, and as you can see, I can initialize this. Now, I've only really touched the surface of what you can do here, but, this would just be the creation of the dog, and then, down here, you can do self, dot speak here. And then this can store a function here, right? And this is how you can add your functionality. So now I can do print self dot speak word, right? And then we can create this as a variable here at the top. Make this, I don't know, woof, right? And then when this class is initialized, what I can do is I can actually change all this stuff here. So now I can do, instead of print dog, oh, let's talk about this right here real quick because I think this is important. All an object is a whole bunch of information stored in a table. That's all it is. As you can see here, it stores all this information here in a table, and then when I manipulate things, I'm just manipulating this part, but it's literally just a massive table. That's all an object really is. Traditionally, this is JSON in other languages, but this is just a Lua table. All right, but now I can do, dog. Oh, come on. Dog. Dog. Dot speak. And as you can see, it speaks. Look at that. And then I can wait 3 seconds and do dog dot speak word. I have access to it. It is now equal to not woof. And then I can do dog dot speak again. So yeah, object-oriented programming in action in the way you should actually do it and in the most common setup. So let's go ahead, come back down here. I'm going to clear the console. Hopefully my object initializes correctly here. There's my thing, there's woof. It's then going to change the property and you have not woof. And there you go. So I want to keep this video short here, so I won't go too in depth here, but this was just a great example of object-oriented programming and why it's so powerful. Because guess what? You make a whole bunch of objects for a game. What's stopping you from taking those objects and doing copy, paste into another game? Nothing. So your objects are incredibly portable between games. And that's why object-oriented programming is so powerful. So if you guys have any questions, I know this was a more advanced video. We're truly showing you guys how to be a professional when you do object-oriented programming, like what it really looks like. I think the last thing I also want to show you guys just super fast is you can actually store all of this information, I believe, in this table. And again, this is why that index worked, because I think now I can just do this, like this. And you can actually declare all your base properties of everything here. So you could do this for organization's sake, and I think we need commas after each one of these. There we go. And as you can see, another great way to store stuff. This should initialize the same way, but because I did this right here and because I have this right here, anytime I type in anything here, it's gonna pull all of this information and put it in here. And you'll still have access to it the same way, I believe. Let me double check here. Yes. And that again is what makes object-oriented programming just incredibly powerful and why you should do it in all of your games. So let me know if you guys have any questions. Please feel free to leave them in the comments, and I will see you all in the next one.